All right, so today we're going to look at systems of equations. So we need some color, straight edge. Oh, inequalities, yes, thank you. What are your rules in an inequality when you're graphing it? How do you know whether you have a solid or a dotted line?
Solid is greater than or equal to, or like it goes with this line.
Yeah, you know you have a solid line if it's less than or equal to or greater than or equal to. In other words, if you had this equals to under there, you're going to fill in a solid line. If it's missing, just less than or just greater than, you have a dotted line. It's like open and closed circle on the number line, right? And then you have to decide how to shade. Greater than is shading above the line, and less than is shading below the line. You can think of any line, no matter how it's tilted. If this is my line, think of this as a hill, like a mountain, right? This would be the ground, correct? Wouldn't this be the top, where the air is, the sun is shining, plants and flowers are growing, right? This is where grass grows, above the ground. Grass does not grow below the ground, correct? And then down here would be where, you know, dead bodies might be buried, right? That's pretty good for me. So this is where things are buried, right? Below ground. So this is below ground. Okay. Then you think of the number line. If you have a perfectly horizontal line, positive is above, negative is below, right? So this would be above the line, this would be below the line, right? Vertical line, greater than, numbers are greater than to the right, aren't they? And numbers are less than to the left. So there's your rules in a nutshell. If you have a slope going in the other direction, where's the grass going to grow? Left or the right side? The right side, so that's above the line. Where are things going to be buried? Because that's below ground. And the left side, right? So it doesn't matter which way it's tilted, positive slope or a negative slope. Still think of that in terms of a mountain. All right, so let's look at example 1. When you have just one variable, an x or a y, doesn't that mean it's a vertical or a horizontal line? So then you are going to plot, pretend like this is x equals 1, just x equals negative 1. Find the x-axis and plot a point at negative 1. There's where x is negative 1. You want to cut the axis that you just plotted a point on in 2 pieces. Do you cut the axis in 2 pieces this way? No, it has to go vertically. Am I going to have a solid or a dotted line? Solid. Solid straight line. I want you to label it as x is less than or equal to negative 1. Will my shading be to the left or the right? Left. So it's going to be over here on the left. I'm going to hold off on my shading because I'm using pen. If you're using graphite pencil, just lightly shade, really lightly this direction. Then I'm going to plot the other one. I'm going to plot it as if it's y equals 2. So find 2 on the y-axis and plot that point. There it is. The only way to cut the y-axis into 2 pieces is horizontally, right? So we're going to put a horizontal line. Is it dotted or solid? Dotted. And label that line as y is greater than 2. Then, this is greater than. Isn't that in this direction above? So where's the intersected shading? Upper right, upper left, lower right. Right here. This is your intersection. That's your solution. Your solution is anything on this line right here and included anything here. What about this? What if a point y is on this line? Is it part of the solution? No, because it's dotted. We can come as close to that line as possible, but nothing included on that line is a solution. This line is a solution because it's solid. All right, look at B. You do that yourself. Remember your solid and dotted lines. Now the y equals 0 is interesting. Wouldn't the point be here on the y-axis? Remember, you're cutting the y-axis. Isn't the x-axis our boundary right here? And you want to make sure that it's quite obvious that it's dotted. So make it really bold. If I can't tell your lines are dotted, you might want to put dotted next to the line so I can tell. It's really not above the line. I'll make it thicker. Right? So is your intersection in the upper right, upper left, lower right, or lower left? Because x is greater than, right, and y is greater than, don't they intersect right here? There's your solution. All right, what kind of a graph is example 2? See, that's stuff you had from Algebra 1, 2. What's this going to be? A parabola. Parabolas are normally y equals, aren't they? So I want to get y equals by itself, so I'm going to solve this for y. And if it's y equals, does a parabola open up, down, right, or left? If it's y equals, is it an up or down, or is it a right or left? Y equals. Because sometimes we have x equals. It's up or down. Because remember in algebra, you usually have y equals ax squared plus bx plus c. You first learn how to solve parabolas when they're up and down. And then in algebra 3-4, you learn parabolas that were x equals ay squared plus by plus c. Yeah, they go right and left along the x-axis.
Like half of it.
What do you mean half of it? Well, we'll get there. So this becomes negative y less than or equal to, I'm going to subtract my x squared, and I have plus 1. When I divide by a negative 1, what happens to the inequality sign? It flips. So I get y is greater than or equal to x squared minus 1. Isn't this the y-intercept? Okay, so I'm going to plot negative 1, and it's on the y-axis because that's your normal general parabola, isn't it? So I'm going to plot a point on the y-axis. This is my axis of symmetry right here. And then if x is equal to 1, 1 squared is 1 minus 1 is 0. So if x is 1, y is 0. That means if x is negative 1, y is negative 0, and I want one more set of points. If x is 2, 2 squared is 4, minus 1 is 3. So over 2, up 3. Over negative 2, up 3. So here's, is my parabola solid or dotted? Solid, right?
Do you have a dotted line?
Pardon?
Do you have a dotted line?
Have I had one yet? Yeah, on section B and A. On this one, they're all solid, aren't they?
No, I mean, can you have a solid or a dotted line?
Yes, you could. You absolutely could. And then for this one, and I'm going to show you with a pencil, because the shading gets a little bit trickier. This is greater than, right? Wouldn't this just be inside the parabola right here? Isn't that greater than the parabola? Going like that? And then this is linear, isn't it? Because everything's to the first power. So that gets rewritten as y is less than or equal to, I'm going to add an x to both sides, x plus 1. What's the y-intercept? 1. And then my slope is positive 1. So up 1 to the right 1. Up 1 to the right 1. Here's their intersection. Up 1 to the right 1. Down 1 to the left 1, another intersection. Down 1 to the left. Down 1 to the left. Am I going to have a solid or a dotted line? Solid. So this is negative x plus y less than or equal to 1. Now this shading is less than, right? So this shading is going to go in this direction here. Where do my shadings intersect? That little loopy, right? Right here? This is my solution right here. You might want to put a little arrow right there. That's the solution. So these are kind of fun. I like that. That's my kind of fun. Maybe not your kind. My plans are for the weekend are to do many more pre-calc problems. I'm joking. All right, so this time we have 3 inequalities, right? If you've got 2 variables, you want to solve this for y. So I'm going to subtract x. Negative y is less than, subtracting your x, you get negative x plus 2. I have to multiply everything by a negative 1. The sign flips. Y is greater than x minus 2. So my y-intercept is negative 2. My slope is positive 1, so up 1 to the right, up 1 to the right 1, and so forth. Down 1 to the left. Is this solid or dotted? Dotted. Make sure it's clearly dotted. If there's any doubt at all in my mind, I will mark it as not being dotted. So if you have to write dotted on here to make it clear, do so. So this is x minus y less than 2. So this is greater than, even though that's less than, remember we flip the sign, this says greater than. So isn't my shading this way? Right? Then isn't this a horizontal, or I'm sorry, a vertical line going through the x-axis? So plot a point on the x-axis at negative 2, and you have to cut the x-axis into 2 pieces. Is this line solid or dotted? Dotted. So this is x is greater than negative 2. So greater than means I'm going this way, right? So far the intersection is here. And then my last line is y is less than or equal to 3. Plot a point on the y-axis at 3. Solid or dotted? Solid. Solid as a rock. That's my song for you today. I know you really enjoyed it. Just trying to amuse us, me, and you. All right, so this is less than. So this is my shading down here. Where do all 3 intersect? In that triangle. So I am going to take a different color or darken in really dark that triangle to make sure that your teacher, me, knows where the intersection is. So again, you might want to put a little note here saying solution. That's what I mean. That's where the solution is. So far that's not really difficult, is it? Flip it. Look at that one. The x's and the y's have the same coefficients, but the 6's are different. Look what happens when, first of all, well, let's go ahead and solve these for y. So I'm going to subtract the 2x. So I get 3y is less than negative 2x plus 6. Then to solve for y, don't I divide everything by 3? This divided by 3 is y, less than, this creates a fraction, negative 2/3 x, 6 divided by 3 is 2. So I'm going to go ahead and plot that. My y-intercept is 2. My slope is negative this time. So you have to go in one negative direction and one positive direction. I don't care where you put the negative, but you make a choice. I'm going to put the negative in the numerator. So I'm going to go down 1, 2 to the right, 1, 2, 3. Now I'm pointed in the negative direction. Down 1, 2 to the right, 1, 2, 3. I can also reverse it. I can put the negative in the denominator, and I can go a positive 2, but a negative 3. That would mean I'd go up 1, 2, but to the left, 1, 2, 3. Is this line solid or dotted? Dotted. And so this one is 2x plus 3y is less than 6. This is less than, so my shading is below where things are buried, right? Then, this line over here, we're going to solve the same way. I'm going to keep 3y, but move the 2x by subtracting it. So 3y is greater than negative 2x minus 6. Same thing happens when I divide everything by 3. I get y is greater than negative 2/3 x, but a minus 2. Don't they have the same slope? What kind of lines have the same slope? Parallel lines. But this one has a y-intercept of negative 2. So I'm going to go down 2 to the right, 1, 2, 3, down 2 to the right, 1, 2, 3. I guess I should do more there. So down 1, 2 to the right, 1, 2, 3. And then up 1, 2 to the left, 1, 2, 3. Up 1, 2 to the left, 1, 2, 3. Solid or dotted line? Dotted also. But this one says greater than. Doesn't that mean my shading's going in this direction? Where's the shading intersecting? In between the two lines. So here's the intersection. I'm going to make that a different color or really, 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 really dark. And this line is 2x plus 3y is greater than negative 6. Next, these are also parallel lines, so when we solve this one, we get y is greater than subtract x plus 3. And this one right here, y is less than subtract x, negative x minus 1. So if I plot the first one, my y-intercept is 1, 2, 3. I have a negative slope of 1, so down 1 to the right 1, down 1 to the right 1, down 1 to the right, and so forth. Or up 1 and to the left, up 1 to the left. Is this solid or dotted? Dotted. So my dots are a little off because we don't have graph paper. Don't let that bother you. X plus y is greater than 3. But this one's greater than, so my shading goes above the line in this direction, right? When I plot the second one here at a y-intercept of negative 1, with a slope of negative 1, they still don't intersect. I still have a dotted line. This one's x plus y is less than negative 1. Where's your shading this time? Isn't it to the left? Down below to the left? Is there a solution to this? No. You must write, you can't leave it like this, you have to write no solution or I won't understand that you know it's no solution. Not every system has a solution. What if we graphed the same line and the shading went this way and this way? Wouldn't that be all real numbers? That could happen. All right, look at number 4. Do you have a question? This time you're just graphing one little thing here. This we're going to get an x. You're going to solve for x this time, not for y. So if you get x by itself, you get x is greater than y squared. That's your parabola that opens right and left. So that means your vertex is on the origin, right? And then if you let y equal 1, what's x going to be? So up 1, y is 1, x has to be 1. Isn't there a point here? If y is negative 1, down here, what's x going to be? Still positive 1. Will x ever be negative? No. So if y is 2, 2 squared is 4, x is going to be 4. If y is negative 2, x is still going to be 4. So this is a parabola that opens to the right. Uh-oh, what did I forget? Dotted, 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 I can't erase, dotted, dotted, super dot, dotted. See, in case you're not sure, that line is dotted. Whoops. So it says greater than. Where do you shade it? If you're not sure, and yes, you do grade it inside, or shade it inside. If you're not sure, can't you do a checkpoint? Can't I check like this point here? What point is that? 2, 0. So put in 2 for x and 0 for y. You get 2 is greater than 0. Is that true or false? That's true. If that's true, then this is where my shading belongs. If it was false, then I would have shaded all out here, right? So this is your solution. And the very last one. What's that a graph of? A circle. What's the center of the circle? What's being added or subtracted to the y and the x? Nothing. So your center is 0, 0. Remember, if it were x minus 1 squared, wouldn't your x value be a positive 1? It's always the opposite sign. What's the radius? 4. So you're going to plot a point at 0, 0, because that's your center. And then you're going to go north, south, east, and west, 4. So up 4. To the right, 4. Down 4. And left 4. Is this a solid or a dotted line? Solid. And I'm going to cheat. Yippee. I'm going to use my little wheelie thing. Only if you buy your own. Looky there. That's awesome. I love math tools. All right, so this one says less than. If you're not, what do you think less than is going to be? Oh, well. It's going to be inside, but if you're not sure, isn't 0, 0 a great checkpoint? Right? Put 0 here and 0 here. That'll give you 0 on the left, won't it? Is 0 less than or equal to 16 true or false? It's true. So that means only the inside of the circle. Now, if it were greater than or equal to 16, you would have shaded outside the circle.